In this video, we are going to solve logarithmic inequalities, and these are the 4 problems that we will solve together. But before we solve these problems, it's still important to remember extraneous solutions, and they will occur for log problems whenever the inside piece is either 0 or less than 0. So this right here is our first problem, and to solve these types of problems, we want to get rid of the log, and so we have to apply our log properties. More specifically, we have to apply the inverse property. If we want to get rid of the log base 3, we can do that using the inverse property. More specifically, we'll use this property right here. So what we're going to do is put a 3 right here, and we'll put a 3 right here. If you do it on one side, you have to do it on the other side. So this is saying 3 raised to log base 3 of x. By doing this, all of this gets canceled, and you just get the inside piece. You just get the x. So we're going to get x is greater than 3 squared. And 3 squared is 9. X is bigger than 9. Now, again, we have to check for extraneous solutions. So if x is bigger than 9, that's fine. Again, we can't have a 0 and we can't have any negative numbers. And x is bigger than 9 could be 9, 10, 11, 12, 12.5. And so this will work. Okay, this will be our second problem. Same procedure. We want to get rid of the log base 4. We can do that using this inverse property here. So we're going to put a 4 raised to log base 4. If you do it on one side, you have to do it on the other side. All of this gets canceled, but the x. So we get x is less than 4 raised to 3, or 4 cubed. And 4 cubed is 4 times 4, which is 16. 16 times 4 is 64. Now this is saying x is less than 64. 63 works, 62 works, 61 works, but less than 64 could be 0. It could be negative. And so for this problem, what we have to do in order to write it out is we have to say that x is bigger than 0, but less than 64. Because again, logs, there's extraneous solutions in that it can't be 0 and it can't be negative numbers inside the log. Now, if you want to pause the video here and attempt this problem, it's a good idea. But same procedure. You want to get rid of the log base 8, so we're going to put an 8 right here. If you do it on one side, you have to do it on the other side. All of this gets canceled, and we get an x is greater than 8 squared. And so we get x is greater than 8 times 8 is 64, so x is greater than 64. And 64, greater than 64 means 65, 66, 67, so no chance in getting a negative number and no chance in getting 0. Okay, our last problem. Now, it's important to remember common logarithms. Whenever there's no base, the base is 10. So let's rewrite this as log base 10 of x is less than 3. Same thing, we want to get rid of the log base 10. So we're going to apply that inverse property of logs. So we're going to put a 10 right here. We'll put a 10 right here. 10 raised to log base 10. All that gets canceled, but the inside piece, which is x is less than 10 raised to 3, and we get x is less than 10 raised to 3 is 10 times 10 is 100. 100 times 10 is 1,000. So x is less than 1,000. But again, less than 1,000 could be 999, 998. But it could also be 0. 0 is less than 1,000. It could also be negative 5. Negative 5 is less than 1,000. And so the way we write the answer is that x is bigger than 0, but less than 1,000. And this right here is our final answer. And that's all we need to do for logarithmic inequalities.